Hello and welcome to the third day on a fascinating topic of organic chemistry, that is stereoisomerism. The entire stereochemistry starts from this topic, stereoisomerism, where the structures remain the same, but the two forms, we don't say two structures, two forms, they are not superimposable.
Good
Maybe,
afternoon.
good afternoon, maybe due to the presence of dissymmetry, or maybe due to the presence of a double bond connected to two different groups at each sp2 carbon. So, did you get the time to watch the video?
Yes, sir, I watched the entire video.
Oh my God, that's great. Usually, I always expect, guess, anticipate that to sit for 2 hours on a video alone without the interaction of a teacher, instructor, is really a Herculean job, which you have done it. So let me share my screen. So we had yesterday learned how to convert the two ways formula and one ways formula to Fisher formula. What is Fisher formula? And then learned CIP rule to determine the absolute configuration R or S. And let me remind you that we spent a lot of time yesterday in understanding the four elements of symmetry: sigma, the plane of symmetry; I, the center of inversion or center of symmetry; then Cn, the n-fold axis of symmetry, simply axis of symmetry, Cn, but improper axis or alternating axis of symmetry, Sn, we also learned, and we knew that the absence of these three elements of symmetry. Om, tell me what elements of symmetry to remain absent in a molecule to make it a chiral, a dissymmetric molecule, such that its mirror image form is non-superimposable with the original form, and the two are enantiomers. They are the optical antipodes of each other.
So first one is sigma, the plane of symmetry. Second one is the I or inversion center, and third one is Sn or improper axis of rotation.
Fantastic. Can you tell me, just try to remember that what is SN? How you visualize an operation which is called improper axis of rotation operation. How it is done?
Sir, two successive operations we have to do to have SN axis. Then symmetry operation is done first. Then sigma
Then
operation.
which axis is to be done first? Which operation is to be done first?
So that's CN n-fold axis.
That is Cn, right?
Yes, sir.
So Cn operation is to be done first, followed by?
So then I think that axis or plane of symmetry operation.
Yes, sigma operation. In which plane? Is it the same plane or a perpendicular plane with respect to the axis?
The perpendicular plane.
Yes, with respect to the Cn axis, if you reflect after Cn operation, if you reflect or a sigma operation is done with respect to a perpendicular plane, then you will get a non-superimposable form. Then that is not called Cn, it is called Sn. Good afternoon, Mr. Rudra.
Good afternoon, sir.
What happened? You got late by 10 minutes? 6
Sir,
minutes? 6.
I'm coming from school. I got little bit late.
Oh, have you taken food? Rice, dal, potato mast, brinjal, eggplant. Eggplant must or fry or say. Have you eaten
No,
your
sir.
lunch?
No, sir.
Then I will not allow you. You ask your mom to give you food. You eat, write, and understand. Okay?
Okay, sir.
Since I am not looking at you now, so you have to eat. Otherwise, we can't spend our time, 2 hours time, fruitfully. I mean, joyfully, with pleasure. If rice dal is not suitable now, you can ask for any snacks.
Yes, sir. Yes, sir. Let's continue.
Okay. Now, Rudra also made a mistake in this. I gave you two. One is a one-edge formula, the other one is a Fisher formula. So I told you which you did not obey my instruction, Miss Tripathi, Miss Sami, Urf, Samini, Saminani. ତୁମେ ମୋର ଇନଷ୍ଟ୍ରକ୍ସନ ମାନିଲନି, ତୁମେ ହିରୋ ମାର୍କା ବନିଗଲ। କିନ୍ତୁ ଆଇ କଂଗ୍ରାଚୁଲେଟ୍ ୟୁ, ତୁମେ ଯେମିତି ବୁଲେଇଛ ଜିନିଷଟାକୁ, କିଛି ଅସୁବିଧା ନାହିଁ। ଯୋଉ ଦିଟା on the plane, these normal lines are lying on the plane, ସେ କ'ଣ କରିଛି, OH ଟାକୁ ଉପରକୁ ନେଇଯାଇଛି ଆଉ ଭାଇନିଲ ଟାକୁ ଏପଟକୁ ନେଇ ଆସିଛି, but they are lying on the plane। କଲେ actually ଯୋଉଟା above the plane ସେଇ above the plane ରହିବ, ଯୋଉଟା below the plane ସେଟା below the plane ରହିବ। ସେ concept ସେ use କରିଛି କି କରିନି doesn't matter, କିନ୍ତୁ ମୁଁ ମୋଟେ କହିନି ମୋ instruction କୁ follow କର, କାହିଁକି ନା ତୁମକୁ ଆଗକୁ ବହୁତ ବାଟ ଯିବାକୁ ପଡିବ। So ଦେଖ, ତମେ ମୋଟେ follow କରିନ, for which I am angry with you, I am mad at you। ଯୋଉଟା ତଳକୁ ଯାଇଛି, जोटा एथिलटा आग गोटे वर्टिकल पोजिशन रे रखी दियो। द वर्टिकल पोजिशन एक्चुअली इट इज लाइंग बिलो द प्लेन, सो मु ऊपर रखी देली, तळे भी रखी पार थांती। देन सिक्वेंशियली जोटा आरंभ कली ओएच रु, ओएच टा एठी लिखिली, मो इच्छा जोटी लिखिबी, तार क्लॉकवाइज रे अछि भाइनिल, तार क्लॉकवाइज रे अछि भाइनिल, तार क्लॉकवाइज रे अछि, एटा तो सरी जाइछि, आ काम बढ़ी जाइछि, इथाइनाइल, तार क्लॉकवाइज रे रखिछि इथाइनाइल, हे गला। Then numbering kali, group ro assignment kali, priority number 1 hochi OH, because oxygen atomic number is more. Then between ethinyl, vinyl and ethyl, ethinyl is greater than vinyl, then ethyl, as we know. Then number 2, number 3, number 4. So number 4 fortunately is lying below the plane. That means it is occupying in a vertical position. So normal CIP rule will be applicable here. So I will C1, C2, C3, then my eye is rotating anticlockwise. I will put an anti-clockwise sign here in the middle. So it is S. Normal rule is S. So this is S, and the name of this, I don't know whether you have written correct name, Miss Tripathi, but Mr. Rudra has written the correct name. That is the start 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 is this. In that case, the all position is 3 in from whichever side you will get. So in case when in and wine positions are same, then in gets the precedence. That is the rule. So 1, 2, 3, 4, 5. This is the nomenclature numbering, not the assignment of groups, priorities of groups. So this will be all, and this will be 3 ethyl and then pent. 1 in, E will be deleted, Y is taken to a vowel, then 4 wine, again E will be deleted, and 3 all. In and wine, they appear as suffixes, primary suffixes, co-suffixes, primary, and in this case co, both are there, in is there, wine is there. So, and the designation is S. We can better write if there are multiple carbon atoms. The chiral center is 3, sometimes it is written 3s. Since there is only one chiral center, so there is no point in writing 3s. But if there are multiple chiral centers, you have to assign the IUPAC number, the locant of each chiral center separately with comma in between them. We will be doing that today. What you did, I am showing you, Miss Midha. Medha. Now, supposing according to my question, supposing these two, the white, you consider white as vinyl, which is up, and OH is, this red one is, and both are lying in one plane in my palm. So green is above the plane towards me, that is ethynyl, and ethyl blue is below the plane. I am the observer, not you. So what she did, she brought OH up. Automatically this will come here. But same green was above on the right side. But now the same green will be above in the left side. Doesn't matter, it is above the plane. And the same, ethyl will be below the plane. So that means if she has done like this, I am telling you, she has done like this. She has done like this. She has brought OH here and then vinyl here. And then the group which is above the plane is same, which is correct. And the which is below the plane is ethyl. That means C is then number 1, number 2, number 3. So C, number 4. C is using the normal rule. Since the least priority group 4 is lying below the plane, so if the eye rotation will be made from 1 to 2 to 3, then normal rule will be followed. Anti-clockwise is S, clockwise is R. That is why I was really scared to tell you both the rules. So it is anti-clockwise, normal rule, and it is S. You understood, Miss Medha?
Yes, sir.
But don't do like that. You convert it to Fisher formula and do. Now see, the second case, I have given Fisher formula where the number 1 group is OH, number 2 is vinyl. Vinyl is senior to propyl because this is to be treated as bonded to 2 carbons. This is also bonded to 2 carbon. So This carbon, there will be one carbon and two hydrogen, but this carbon is two carbons and one hydrogen. So vinyl is senior to propyl. So number 2 is this, and number 3 is propyl, and then ethyl is number 4. Now the number 4 is falling in the horizontal position, that is above the plane. And if I do not like to bring it to a vertical position to apply the normal rule, I will apply the opposite rule. That is what we funnily called the golden rule. Then you look 1 to 2 to 3, anticlockwise, but golden rule. Anticlockwise. So it is R. Or to apply the normal CIP rule, we have to make two switches. By making two or any even number of switches, the configuration is retained. So that if you want to bring it here, so you take here, bring it here, and so I told there is a merry-go-round sequential shift between three groups will make two switches. So ethyl will be coming up, propyl, I write NPR, N-propyl will be coming left, and OH will be coming here, keeping the vinyl fixed. So this sequential shift of three groups while keeping one fixed, the other fixed, will make two switches. So now number 1, 2, 3, 4. Now we'll be applying normal rule. 1 to 2 to 3 clockwise R. And the name of this compound will be 1, 2, 3, and this will be 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6. So it will be R 3 ethyl, then hex 1 in, E will be deleted, then 3 on. And the designation is R. And you can write 3R, it is okay. If only R, it's okay. You got it? Now, I want to show what Miss Medha did, so that she can understand her mistake. And I will give you many more, so that Medha, see. Now you see what you did. You disobeyed my instruction and continued to play with one way's formula. Doesn't matter. You did it correctly. ମୁଁ ଦେଇଥିଲି OS ଟା ଲେଫ୍ଟରେ ତମ ଉପରକୁ ନେଇ ଆସିଲ, ଭ୍ୟାନିଲଟାକୁ ଏପଟକୁ ନେଇ ଆସିଲ, ଏମିତି ଗୋଟେ ରୋଟେଟ୍ କରିଦେଲ ମଡେଲଟାକୁ। ସୋ ଇଥାଇଲଟା ବାଁ ପଟକୁ ପଳେଇ ଆସିଲା, still above the plane, and ଏଥିଲଟା ଡାହାଣ ପଟକୁ ଟିକେ ପଳେଇ ଆସିବ, ଟିକେ ଜାଗା ଚେଞ୍ଜ ହେଇଗଲା, କିନ୍ତୁ still below the plane. So you are applying normal rule. Normal rule anti SCW लिखि देइछो, जो SCW anti clockwise, normal rule रे anti clockwise टा कोन होयो? Miss Samita कोन?
Yes.
Yes. सेठी तमे लिखिबा कथा, मु देखिबा कथा normal rule apply कलो कि golden rule. Henceforth मु जो whatever home task I will give, you mention as a beginner, you mention normal rule. SCW is S. Normal rule CW is R. Golden rule SCW is R. Golden rule CW is S. उल्टाटा. So एटा कौन भूल कलो देखो, तुम्हें गोटे मेरीगो राउंड कर दे, मेरीगो राउंड चारटा भितरे कर देलो, चारिटा भितरे मेरीगो राउंड इज नॉट टू स्विचेस. देखो OS टा ऊपर गला, प्रोपिल टा इथाइल जगह को आसला, इथाइल टा तळु को आसिला, एंड भाइनिल टा एठी गला. एमिति कला, इट इज नॉट इक्वल टू टू स्विचेस, इट इज ऑड नंबर ऑफ स्विचेस हला. So the configuration is inverted. मु जोटा देइची तार उल्टाटा, एवं उल्टा हबा कथा, एस हबा कथा, कहीं नंबर 1 एटा OH, नंबर 2 होची भाइनिल ठीक करछ, नंबर 3 होची प्रोपिल 4. So एटा normal rule रे पडुची ethyl is falling in a vertical position, that means below the plane. So 1 रु 2 रु 3 देखले anti clockwise normal rule रे एठी ए सभा कथा तमे जबरदस्ती आर लिखिछ. So you are not writing whether you are applying normal rule or golden rule, you are not. And first of all, the conversion is entirely wrong. तमे जदि नबाकू चाहूच इथाइल को तळुकू ताहले एई उपरटाकू प्रोपिलटाकू फिक्स रखितांत ए तीनिटा भितरे सिक्वेंशियल एंटी क्लॉकवाइज एटा इथाइल एटा आस्तांता, भाइनिल एठी जाइतांता, ओएसटा एठी के आस्तांता. प्रोपिल रो पोजीशन एठी थांता सेमति बरकरार. बुझि परलो तो केमति गंडोलिया कलो?
Yes, sir.
सिथमे मु कहली एवरीथिंग हैज बीन मेस्ड अप. प्रथमटा ठीक करिछ किंतु रूल अप्लाई करिकरी भूल आंसर पाइछ. द्वितीयटा बाय मिस्टेक करेक्ट आंसर देइछ किंतु जो स्ट्रक्चर लिखिछ सेथुरु एस हवा कथा किंतु आर देइछ. किंतु ये मध्य तमर भूल अछि. काहे कि ना आमर दीटा कार्बन एठी दीटा कार्बन एथाइल रे दीटा कार्बन, कार्बन नंबर रिमेनिंग सेम. इफ ए फंक्शनल ग्रुप लाइक डबल बॉन्ड goes in a principal carbon chain, then you have to include the double bond, exclude. हाँ जदि एठी इटी जगह रे आउ तीनटा कार्बन थांता, प्रोपिल थांता, तेल वाइनिल ही थांता बा एथिनिल ही थांता. बट एठी दुईटा एथिल रे भी दीटा, से केस रे तुमको एथिल बाट दे कि जीवा को पड़िबो. क्लियर है?
Yes, sir.
सो नाटा भी भूल हला, एईटा भी ना भूल हला. प्रोपान वालू नुहे 1 2 3 4 5 1 2 3 4 5. सो डबल बॉन्ड ट्रिपल बॉन्ड को रखिबा को पड़िबो. जदियो you could have deleted double bond triple bond by going to ethyl, but since double bond triple bond are functional groups and number of carbon same, then you have to include both double bond and triple bond and remove, I mean, exclude ethyl as a branch, as a prefix. Got it?
Yes, sir.
So do it once again and show me after the class is over, or when you get free time after the class. Got it?
Yes, sir.
Now, in this, before I give you some more examples, I would like to play toying with Fisher formula. FF. Number 1, A, B, C, D. If you make a 180-degree rotation of the model, that means A comes here, C goes up, D comes here, B comes here, then configuration remains the same. Retention of configuration. I am showing you so that once you know the rule, so an example I am giving you so that, supposing methyl OH, simple example I am giving you H and OH. I'm sorry, OH likely that will be achiral. COH, same lactic acid. Now, determine the configuration, all of you. I give you 1 minute time. Let me, hello and welcome those who are watching, have started watching from the YouTube directly, who's are following. So, it's really a challenging job to follow and acquire the knowledge to such an intricate level, which is required for an IIT advanced aspirant.
Sir,
Yes.
sir, S.
Ki koila S? Ku
Sir,
bada?
me.
Au ki koila ki?
No, sir.
Okay. तमे केमि जान? तम ऊपर ओवरलैपिंग हेथियो वॉइस टा? देखि देले पुरा कहि देई हबो? एते समय लागुची माने आउ 2-4टा तुमको करिया को पड़ियो. ओम
Yes, sir.
कौन
Sir, yes.
नानी
Yes.
हाँ
Yes.
देखो नंबर 1 is OH, number 2 is carboxyl, number 3 is methyl, number 4. So tell me, Samita, which rule you will apply? Normal or golden?
Sir, normal.
Normal, because if the least priority group 4 is occupying any vertical position up or down, then normal rule. 1 to 2 to 3 anticlockwise, so S. So this is S lactic acid, which is fortunately or unfortunately plus. Now we will make a 180-degree rotation of the model. It's not a sequential exercise that Sami did, that we will do. Another rule, toying with formula. Because Sami's answer made me remind to do this. Supposing I will bring methyl down and H up, and COH here and OH here. Then what will happen? Number 1, 2, 3. Again 1 to 2 to 3 anticlockwise S. Yes or no?
Yes, sir.
Number 2 rule. যদি 90-degree rotation করিব, configuration is inverted. 90-degree rotation, that means what Miss T did, Miss Tripathi. 90-degree rotation মানে A আসিব এটিকি, D আসিব এটিকি, that is a sequential shift among all the 4 groups. ये ता जागाକୁ ଯିବ sequentially, ତ 90-degree rotation ହେଲା, C ଟା ଯିବ ଏ ଜାଗାକୁ, B ଯିବ ଏ ଜାଗାକୁ. So it will be inverse ଲେଖିଦିଅ ଏଠି, ସେଠି ଲେଖିଲ retention of configuration, inversion of configuration. ଗୋଟେ example ଦେଲେ ଜାଣିପାରିବ. ଏଥର ଟିକେ ଅଲଗା ଦଉଛି. ethyl, methyl, vinyl, से क्लोरो ଏବଂ ତାପରେ ମୁଁ 90-degree ଟର୍ନ କରିବି. এটা কোন ବାହାର କଲ ଆଗ? What is the configuration of this molecule, which is 3-chloro, 3-methyl,
Sir,
pent
S.
1-in, pent 1-in.
Sir, S.
কি কইলা এটা?
Sami.
হোম কাই বন্ধ কল, খোলুছো বন্ধ করছো কোন? কনফিডেন্স আসুনি?
Sir, R. হচ্ছে।
আর হচ্ছে তোমার নাই সময় নানি?
Yes.
Sir, R আসুଛି.
আচ্ছা ঠিক আছে ଦେଖିବା. Now number 1 is chlorine, number 2 is vinyl, number 3 is ethyl, number 4 is methyl. But now the least priority group occupies a horizontal position above the plane of the paper. So will you apply directly to this form, this Fisher formula, or you will bring the methyl group to a vertical position? What do you want? If in this formula, then which rule you will apply, normal or golden?
Sir, golden.
Golden.
Misty.
Sir, golden.
If golden, because this is occupying a horizontal position above the plane, then 1 to 2 to 3 clockwise. So clockwise means it is S. Just the opposite. Clockwise is R normal, but clockwise is S golden. So who told it is S? It is Rudra who is now confident, but you both are not confident. You are clockwise ହେଇଗଲା. clockwise ହେଲେ R ହବ normal rule ହେଲେ, କିନ୍ତୁ ଏଇଟା ତ ମିଥେଲଟା ତ ଅଛି horizontal position ରେ, ଏଠି ଉଲ୍ଟା rule apply ହବ. How you will be saying it is R, it is S? ଯଦି ତୁମେ ଚାହୁଁଛ, ସେଇଥିପାଇଁ ମୁଁ ତ ଆଜିକାଲି ଟିକେ ହିରୋ ମାର୍କା ମୁଁ ହେଇଗଲିଣି. ଆଗେ ମୋଟେ କହୁନଥିଲି, ଆଗ କହୁଥିଲି ନାଇଁ ତମେ ଆଣ, ମୋଟେ ରୁଲ ତ କହୁନଥିଲି, ଗୋଲ୍ଡେନ ରୁଲ ମୋଟେ କହୁନଥିଲି। ପିଲାମାନେ କୋଉ କୋଚିଂ ଫୋଚିଂ ଜାଣିଲେ ଜାଣିଲେ, ସେ ତାଙ୍କର ଯାହା କଲେ କଲେ, ମୁଁ କହୁନଥିଲି। ମୁଁ କହୁଥିଲି ସବୁବେଳେ ଯେ ତମେ ଆଣ, ଆଇଦର ଉପରକୁ ନିଅ ତଳକୁ ନିଅ, ଧର ମେଥିଲ କୁ କ୍ଲୋରିନ ଟାକୁ ଫିକ୍ସ ରଖିବା and then make a anti-clockwise sequential shift। ମୁଁ ଚାହୁଁଛି ଉପରକୁ ନବା ପାଇଁ, ମେଥିଲ ଉପରକୁ ଗଲା, ଆଉ ଏଇଟା ଏଇଟା କଣ ସେଟା ଏଥିଲ, ହଁ ଏଥିଲ ଆସିଲା ବାଁକୁ and ଭାଇନିଲ ଆସିଲା ଏଠିକି, এটা ফিক্স রইলা। তো নাও নর্মাল রুল অ্যাপ্লাই করিয়া 1 to 2 to 3 and 4, এটা 4 is lying in a vertical position, we'll be applying the normal rule 1 to 2 to 3 anti-clockwise, so it is as normal rule. And I converted this with 2 switches. 2 switches means no change in the configuration, retention of configuration. Now let us make it a 90-degree rotation, which Miss T did. क्लॉकवाइज करो कि आंटी क्लॉकवाइज करो। एथिल आसला एठिकी, मेथिल गला तळुकू, क्लोरीन गला एठिकी, एंड देन भाइनिल गला एठिकी। Then number 1, number 2, number 3, number 4, and here which rule you will apply, Omkar?
So normal rule.
Normal. Then number 1 to 2 to 3 clockwise, so this is R. Is it not inversion of configuration, Miss Tripathi?
Yes, sir.
So these are the 2 things which you can play with the structure. So I will give you another, and after you do, I will ask you to annotate. So the chiral center is bonded to 4 different groups. It is dissymmetric. 4 groups are chloro, carboxy, hydroxymethyl, and methyl. Well, I'm sorry. Let me allow me to make a little change. Make it bromomethyl. Just sorry. I want to make a change. Not hydroxymethyl, then my purpose will be foiled. Take your time. I'm not going anywhere. Then we'll go to 2 chiral centers, then 3 chiral centers with pseudo chirality, and then more than 3 with multiple, with symmetrical structure and unsymmetrical structure.
Sir, S.
And also name the compound. Don't shout. You name and I'll. कौन खाइल किछि?
Yes, sir.
ତାହେଲେ ଭାତ ଖାଇବ ସନ୍ଧ୍ୟାରେ ନା କଣ? ଆମେ ତ ଓଡିଆ ଲୋକ, ଭାତ ନ ଖାଇଲେ ହବନି। ଡେଇଲି
Yes, sir.
ଭାତ ନ ଖାଇଲେ ମୋର ବି ସେଇଆ। Once a day I must eat rice. Because we belong to the eastern part, almost south. When you go to Delhi and to any UP or a Delhi or maybe to a higher latitude, you talk to them in Hindi, they will immediately say, do you belong to the South India, Southern India? So relative to Delhi, we are South India, and relative to us, Tamil Nadu is South India relative to Andhra Pradesh. Tamil Nadu is South India. कौन हला कौन
सर
कॉन्फ़िगरेशन
कहबे
नहीं नहीं कॉन्फ़िगरेशन हला कि ओमकार एंड समिता
Sir,
More
S.
S. You have to follow my instruction. କରିକି ଲାଭ କଣ ତମେ ତମେ you want to do it quickly or in your own way ଯାଇକି ଠିକ କରିଥାନ୍ତୁ ମୁଁ କରିଦେଇଥାନ୍ତି ତମକୁ ଦାଦ ଦେଇଥାନ୍ତି ପ୍ରଶଂସା କରିଥାନ୍ତି ନିଶ୍ଚୟ କିନ୍ତୁ ଭୁଲ କଲେ ମୁଁ କହିବି ନାହିଁ କାହିଁକି ଫଲୋ କଲନି ମୋ ଇନଷ୍ଟ୍ରକ୍ସନ କଣ ବାହାରିଲା ସମୀ
Sir, S.
ଚାଲିଛି ନାଇଁ
No, sir, S.
yes ଆଚ୍ଛା ଦେଖ ମୁଁ କଣ କଲି ୟାକୁ କନଭର୍ଟ କଲି ଟୁ ଫିସର ଫର୍ମୁଲା ଯୋଉଟା ତଳେ କ୍ଲୋରିନ୍ ଅଛି ସେଟା ଗୋଟେ ଭର୍ଟିକାଲ ପୋଜିସନ ରେ ତଳେ କିମ୍ବା ମୁଁ ତଳେ ଲଗେଇଲି ଦେନ୍ ମୁଁ ଷ୍ଟାର୍ଟ କରିବି ମୁଁ ଗୋଲ୍ଡେନ ବାଲା ମୁଁ ଷ୍ଟାର୍ଟ କରିବି ମେଥିଲ ରୁ ମୁଁ ଷ୍ଟାର୍ଟ କଲି ମୋର ଇଚ୍ଛା ମୁଁ ଯୋଉଠୁ ଷ୍ଟାର୍ଟ କରିବି ମୋ ଇଚ୍ଛା ଦେନ୍ ତାର କ୍ଲକ୍ ୱାଇଜ ରେ ଅଛି କିଏ ନା ବ୍ରୋମୋମେଥିଲ CS2Br ତାର କ୍ଲକ୍ ୱାଇଜ ରେ କିଏ ଅଛି ନା କାର୍ବକ୍ସିଲ ବାସ୍ ହେଇଗଲା ये जा ये सैया देन नंबर 1 किए क्लोरीन देन बिटवीन ब्रोमोमेथिल एंड कार्बोक्सिल के सीनियर
सर ब्रोमोमेथिल
यस अमिता
No, bromomethyl.
प्रिसाइजली एठी तीनिटा ऑक्सीजन कार्बन को तीनिटा ऑक्सीजन लागिची अकॉर्डिंग टू रूल एठी डबल बॉन्ड ओ अछि माने सेठी दीटा एवं आ गुटे ओ फिर भी गोटे ब्रोमीन इसका पल्ला भारी पड़ेगा तो ब्रोमोमेथिल इज सीनियर टू कार्बोक्सिल सो नंबर 2 इज ब्रोमोमेथिल then number 3 and number 4 is methyl ମୁଁ ଜାଣିକରି methyl को horizontal position रखिली कारण मोर इच्छा हला golden rule apply करिवि so that ମୁଁ golden rule अनुसार number 1 number 2 number 3 clockwise बुलिला clockwise golden rule होची S यदि normal rule हेतंदा R S so what is the name of this compound yes
हम कहे
yes
सर 2s 3 ब्रोमो 2 क्लोरो 2 मिथाइल प्रोपानोइक एसिड
2 chloro
2 मिथाइल
ଆଉ
सर आगत 3 सर आगत 3 ब्रोमो
हाँ आग 3 ब्रोमो सॉरी 3 ब्रोमो
2 क्लोरो
2 क्लोरो
2 मिथाइल
2 methyl
प्रोपानोइक एसिड
propanoic acid correct कारण जदि आमे nomenclature wise numbering करिवा नंबर 1 2 3 एपटे आसुची किंतु एठी नंबर ऑफ ब्रांचेस अधिका होची ब्रांचिंग रूल फॉलो करूने ब्रोमीन गोटे ब्रांच आ जाई ना तेणु एई पटे जीवाक पड़ियो तुमको 3 3 होची एपटे किंतु एपटे गले ब्रांचिंग रूल को आमे फॉलो करूचे सो मेथिल गोटे ब्रांच क्लोरो गोटे ब्रांच सो हेला कोन ना 3 ब्रोमो 2 क्लोरो 2 मेथिल प्रोपानोइक एसिड एंड 2 पोजीशन टा कायरल तेणु 2s दियाला हेला हेची
Yes, sir.
Yes, sir.
अच्छा आ गोटे मु दउची गोटे hypothetical compound मु तैयारी कली I am not bothered whether this compound exists or not, but I want you to assign its configuration. This is Mercapto group, thiol group. So it is a counterpart of alcohol, which is a type C functional group, Hiromarca group. So it will be alkane thiol, 2 thiol or 3 thiol, whatever. You want thiol. Amino group is junior to thiol.
सर एस
Yes, sir, S.
केमती जानलो ना सल्फर होची नंबर 1 नहीं नंबर 1 होची 17 एटा एटॉमिक नंबर एटा 16 तेणु नंबर 1 होची क्लोरो देन एसएच देन नाइट्रोजन होची 7 कार्बन होची 6 देन 3 होची एटा एंड 4 होची एटा तो भाग्य को हमें नॉर्मल रूल विल शैल बी अप्लाइंग so 1 to 2 to 3 anticlockwise so it is S. What is the name of this compound? Yes, 1 amino 1 chloro ethane thiol 1 chloro 1 amino ethane इटा रहिबो थाइल आउ तो 2 न थाए इथेन थाइल कौन रुद्र फ्लैट हे गलो कहि परलनी
सर और टिके टाइम लगता
ओके एठी मु गुटे देबी D is different from H and its priority is more than H. If D would have been H, it would have been achiral, optically inactive. But gote jodi D asibo, it is a chiral center. That is a chiral carbon. It has got a R and S. We have to determine that. And Mukoichi, D is senior to H. Koichi na nahi?
Yes, sir.
Omkar, have you written in the copy? Have you written
Yes,
in the
sir.
copy?
Yes, sir.
सर एस
I was really worried about you because it is really difficult to miss out a class with the instructor and what's because you were so committed, you had passion, so you made it. It's not possible. I wish that Ansul can do it, but it's very difficult. I don't say it is impossible. It is very, very difficult. S, samaste unanimous in S.
यस सर
Yes,
Miss Tripathi,
Yes, sir.
कौन कौन पाई
Sir,
कहिथिलो?
yes, sir.
Okay, I'm so sorry. Number 1 होची आपनकर एटा, number 2 होची methyl, number 3 होची deuterium, number 4 normal rule. So 1 to 2 to 3 anticlockwise. So this is S. And the name of this is 1 deuteroethanol. 1 2 1 deuteroethanol. Now I think tomorrow he will ani. Is it okay or I'll give you one more? Miss Tripathi jaha kahibe.
Sir, ଆଉ ଗୋଟେ
Acha, this time I will give you the 2 ways formula. One is 2 hydroxyethyl, the other one is hydroxymethyl, the other one is a hydroxy, the third one is aldehyde bonded to the chiral center, the tetrahedral center. Now this is very simple. The
सर एस
2 ways formula is very simple. Jota above the plane, seta horizontal. Jota below the plane, seta vertical.
सर एस
खाली relative priority टा कौन? Tell me which is the relative priority, aldehyde, hydroxymethyl, ethyl. কোটা হবো?
Sir, aldehyde.
Aldehyde রে দুইটা অক্সিজেন অ্যাটম লাগিছে, ডবল বন্ড মানে as if it is two oxygen atom, as if এটি লাগিছে তো এটা, সো এটি ও এটি ଆଉ ଗୋଟେ ଓ, ତେଣୁ କାର୍ବନ କୁ দুইটা অক্সিজেন লাগিছে, এটি কার্বন কু গোটে অক্সিজেন, এটি কার্বন কু কার্বন লাগিছে, তেণু নম্বর 1 গ্রুপ হচ্ছে এইটা, নম্বর 2 হচ্ছে এইটা, এটা নম্বর 3 নো ও এটা তো নম্বর 1, আই এম সরি, বিটুইন দি কার্বন বেয়ারিং গ্রুপস এইটা নম্বর 1 এর, এটা অ্যাকচুয়ালি 2, এটা 3, এটা 4, হয় কি নাই?
Yes,
Yes,
sir.
sir.
এটি কার্বন কু ডাইরেক্টলি অক্সিজেন লাগিছে, এটি কার্বন কু লাগিছে কার্বন, তেণু আমি যেତେବେଳେ কনଭର୍ଟ କରିବା ହାଇଡ୍ରୋକ୍ସି ଯୋଉଠି ଅଛି ସେଇଠି ଖାଲି ସିଧା ହେଇଯିବ ଆଉ କ'ଣ, ତଳେ ଥିଲା ତାର ସ୍ୟାଡୋ will be vertical and our shadow will be horizontal, CH2 CH2 OH, this is OH ହେଇଗଲା, and then କ'ଣ ହେଇଥିଲା ତମର ସମିଧା? S ନା
Yes, sir. S ହେଇଥିଲା।
ସବୁ କ'ଣ S ଆସିଲାଣି, 1 2 3 4, ଚାରିଟା ପଡୁଛି ଏଠି, କୋଉ ରୁଲ ଆପ୍ଲାଏ କରିବା?
The golden.
So 1 ରୁ 2 ରୁ 3 clockwise, clockwise ମାନେ S, because we are applying the opposite rule. So name कौन हबो? S तो ହେଇଗଲା, तो what will be the name? Name ପାଇଁ ଅଲଗା rule, ତାର ନମ୍ବରିଂ ତାର ସିଷ୍ଟମ ଅଲଗା, priority rule ତାର priority assignment ସବୁ ଅଲଗା, CIP rule is different. କିଏ କହିବ? longest chain is the rule, गोटे हीरो बाकी सब जीरो, aldehyde is zero, so मु नंबरिंग करछि, आ गोटे तमे पेंसिल रे नंबरिंग करि पारो किबा पेन रे, don't disfigure the CIP assignment, 1 2 3 4, एठी 1 2 3 एई थांता, तेणु aldehyde आल होछि हीरो मार्का, बाकी सबु जीरो मार्का, हाइड्रोक्सी दीटा अछि, डाइहाइड्रोक्सी हे जिवो 2,4 डाइहाइड्रोक्सी, এইটা তো হাইড্রোক্সি মেথিল, এই গ্রুপটা হচ্ছে হাইড্রোক্সি মেথিল, তেণু
Sir, 2,4 dihydroxy, 2
2s তো ঠিক ଅଛି, 2,4 ডাইহাইড্রোক্সি
2 hydroxymethyl butanol
2 হাইড্রোক্সি মেথিল
butanol.
বিউটানল, ଏହା ହେଇଛି?
Yes, sir.
Yes, sir.
ବାଳିକା ତମେ ତ କିଛି କହିଲନି,
Yes, sir.
ଦେଖ ମୁଁ ତମକୁ ଦେଖେଇ ଦଉଛି what this guy is saying, this supposing I will draw a picture like this, I have, I can show this. And I'll just change it to 1 to OH. This one to CS2. এইটা নর্মাল গাড়ি দিয়ে দেওয়া, CS2 C, no বেশি হয়ে গেল নাই, হয় কি নাই?
Yes, sir.
And এইটা CS2OH, CH2OH, OH, এটা CHO, ହେଲା ଏ ତ?
Yes, sir.
Oh sorry, 2s, 2,4-dihydroxy, 2-hydroxymethyl. You have to put it in a parenthesis butanol. Is it nahi?
Yes, sir.
This is the
Yes.
perfect identity of the molecule. खाली गुट्टी 100% hela nahi. Because we do not know whether it is plus or minus. That nobody can say unless one experiments. This is a hypothetical. You can construct infinite number of molecules. Fictitious. Many of them are fictitious, cannot be synthesized. But we can generate the name and configuration. But you don't know whether it is plus or minus. You understood?
Yes, sir.
Yes, sir.
Yes, sir.
ଆମେ ହାଇଡ୍ରୋକ୍ସି ମିଥାଇଲ କୁ ଚନ୍ଦ୍ରବନ୍ଧନୀ ଭିତରେ ରଖିଛି ତ ଆଇ ଏମ୍ ସୋ ସରି ଦିସ୍ ଇଜ୍ ଏ କମ୍ପ୍ଲେକ୍ସ ବ୍ରାଞ୍ଚ ତା ଭିତରେ କିଛି ନିଜର ନମ୍ବର ନାହିଁ ବୋଲି ମୁଁ ତାକୁ ବାହାର କରିଦେଲି नो 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 यू हैव टू कीप एनी complex branch in between even if it is hydroxy methyl you have to put it inside parenthesis it is a complex branch. Okay, now we shall be doing something. Simplest molecule, simplest optically active molecule. Number one, simplest alkane. Tell me which is the simplest alkane which is optically active. What you do, put a cross, start from hydrogen. This is the chiral center, a carbon. Start with hydrogen. Then its next brother is methyl. Next brother is ethyl. Next brother can be isopropyl, can be n-propyl. There can be two possibilities. So, 7टा 3 2 5 1 6 1 7टा कार्बन तळुकू chiral center हेई परिबनी. So this has got another possibility. It isopropyl. But I don't know whether I have drawn it S or R. You will tell me just by looking. You will tell me what configuration I have drawn. And what is the name of this compound? This is the simplest. This formula से नीचे कोई फॉर्मूला ऑप्टिकल एक्टिव हो नहीं सकता क्योंकि 4 डिफरेंट ग्रुप्स चाहिए.
Sir, S.
What is the name of this compound?
Sir, 4-methyl hexane.
Are you kidding me?
The 3-methyl hexane.
1,
Yes, sir.
2,
3-methyl.
3, 4, 5, 6. So this is S, 3S of course. Goes without saying only one chiral center, 3-methyl, what? What?
Hexane.
Same. Or the other possibility is if you make it isopropyl, that also will be, the formula will be C7H16. And particularly this one and the other one, isopropyl, that will be optically active. If this is 3S, it's mirror image. If you make one switch, any one switch, interchange between any two groups, you will get R. They are non-superimposable. They are not superimposable. Now, the simplest alkene, all simplest. So start with a cross. Then the minimum requirement is vinyl. For an alkene, the minimum requirement is a vinyl group. And start with hydrogen, then its elder brother is methyl, then its elder brother is ethyl. So this is the minimum, the simplest alkene which is optically active. The chiral center has to be tetrahedral, not sp2, sp3. So what is the configuration I have done? I don't know.
R. Sir, R.
Kon koucha? Anyone watching in the YouTube can also chat with me in the chat box. What is the configuration of this I have drawn? And what is the name, which is the simplest alkene? Kon hala? Samita, what is this name? Hey, what is the configuration? Koi par na sikai kouchi ago. So number 1 hochi vinyl, number 2 ethyl, number 3 hochi kono na methyl. and number 4, and we are applying the normal CIP rule, 1 to 2 to 3 rotation is clockwise, then it is R. And what is the name of this molecule?
Sir, 3R, 3-methyl pentene.
1, 2, 3, 4, 5. So 3 methyl, you numbering in IUPAC is different. 1, 2, 3, 4, 5. 3 methyl, then what?
Pentwanine.
Pentwanine. Similarly, you can generate the simplest alkyne. And I am not going to spend time. You put a C triple bond CH. This is the minimum requirement for an alkyne, ethynyl group, and start from hydrogen, then methyl, then ethyl. In the similar way, I don't know what configuration I have drawn. Deliberately, I have put hydrogen in the horizontal position so that you will be forced to use the opposite rule, the golden rule.
Sir, S.
Number 1
Sir,
is ethynyl, number 2 is ethyl, number 3 is methyl, and number 4 is hydrogen, which is in the horizontal position. 1 to 2 to 3 clockwise, and the golden rule clockwise is S. And the name of this compound is similarly 3-methyl pent 1-wine. Same, right?
Pent.
1, 2, 3, 4, 5. Pent 1-wine, right?
Yes, sir. Yes, sir.
Simplest
Yes.
alcohol, which we have already done. OH is a must. Then starting from hydrogen, its elder brother. So we already have done secondary butyl alcohol, sec-butyl alcohol. So this is 1, 2, 3, 4, butan 2-ol. And I don't know what configuration I have drawn.
Sir, R.
So this is number 1, this is number 2, number 3, number 4, normal rule. And this is 1 to 2 to 3 clockwise. So this is R butan 2-ol. It is 2R ନ ଲେଖିଲେ ବି ଚଳିବ, cause ଗୋଟିଏ ତ chiral center ଯୋଉଟା ହେଲେ ବି ଲେଖିଲେ ଭଲ, ନ ଲେଖିଲେ ବି ଭଲ, butan 2-ol. And well, this is called sec-butyl alcohol. And supposing I'll ask you draw the S configuration of simplest aldehyde. You have to draw. Aldehyde is a must. Then starting from hydrogen, then methyl, then ethyl. CHO is one position will be occupied by CHO.
Yes, sir.
Now cursor.
Yes, sir.
Yes, sir.
अच्छा नानी ये कलो annotate करो तमे खाता देखी करी एटी कर दियो मोर दरकार S specifically I demanded S ହେଲା
Yes, sir.
देखो ठीक अच्छी नंबर 1 ग्रुप नंबर 2 ग्रुप नंबर 3 ग्रुप नंबर 4 ग्रुप जानिक से रखी नॉर्मल रूल अप्लाई करने एंटी क्लॉकवाइज है दिस इज परफेक्टली यस एंड व्हाट इज द नेम ऑफ दिस aldehyde the simplest aldehyde हेलो अरे ये कौन तार ना कौन समिता
सर कहूछ
सर
सर
कहबे
ना नेक्स्ट टाइम तुमरो पाली पड़िबो
2 methyl
हाँ
butanol
2 methyl butanol से कोई था तो हमकार
यस सर
1 2 एटा 2 कायरल सेंटर टा होची 2 2s लिखले भी चलिबो नॉल नाही ना लिखले भलो 2s second carbon atom according to IUPAC nomenclature is chiral center so 2s then 2 methyl butanol सेमती घरे तमे ड्रॉ करिवो ए काटा तक काटा ताकू मिसी त्रिपाठी सो एटा हम काटी दउछि तमे घरे करिवो देन आउ गोटे घरे करिवो आउ गोटे घरे करिवो सिंपलेस्ट आर कार्बोक्सिलिक एसिड से ही बढ़िया कौन देन आउ गोटे सिंपलेस्ट एस 1 डिग्री अमीन है थाउ से थाउ बोला now before we go to double chiral center I would like you to tell about specific rotation you know alpha d 20 तक लिखा जाए is alpha by c in 12 for every chiral molecule pure chiral molecule ro specific rotation is fixed and that is determined by using the d monochromatic radiation which is 5800 around 90 or 89 angstrom that monochromatic radiation which is made plane polarized by passing through Nicol prism. I will also give a one line notes after that after this and using 20 degrees Celsius that is why 20 degree and what is alpha this is specific rotation which is fixed for a given compound given enantiomer fixed alpha is the optical rotation you do not know what is the you have been given a solution you maybe 2 molar maybe 1 molar maybe 0.1 molar you don't know so whatever solution is given to you you put it in the polarimeter and you got this is the optical angle of rotation but you have to made it for unit concentration unit path length c is the concentration of the solution in a achiral solvent. Water is an achiral the solution because solute is chiral, but you have to take a solvent which is achiral. In an achiral solvent, measured in interestingly gram per milliliter. That is the definition, not moles per liter or grams per 100 milliliter. It is gram per milliliter. That is the unit of concentration used here to find alpha specific. C is the concentration of the solution and D and sorry the L is the length of the polarimeter tube which is a cylindrical tube. The length of the polarimeter cylindrical tube. Polarimeter. In decimeter and that's the interesting part. In decimeter, dm. And of course, capital D stands for the D1 line of sodium, that is the monochromatic line. Only D stands for D1 line, that is 5889 angstrom. of sodium. And 20 stands for 20 degrees Celsius. So, supposing I say D 2-bromobutane, which is optically active, D or plus D. I'm not saying R or S. Is the alpha specific ବହିରେ ଅଛି ଏ ଆଉ ଦଉନି ଇଏ 20 D ଆଉ ଦଉନି ଏଠି it is understood. If you put a square bracket, it will mean D20 is not given, is equal to plus 23.1 degree. Definitely L2-bromobutane will be exactly same because they are pure compound. The alpha specific will be minus 23.1 degree. You understood? So pure D will be, supposing 23.1, that is fixed. Anywhere in the world, it is fixed. Per unit concentration, per unit length of the polarimeter, and that too used in decimeter, and concentration used in grams per milliliter. So that is fixed. The alpha for a pure chiral molecule is fixed. Then I will tell you. Now, I think we have written a statement. There is no fixed correlationship between absolute configuration. We have not written. There is no fixed correlation between absolute configuration that is R and S with relative configuration D and L. It's not that always R is D and S is L. No, कार R टा D ही परे. Then तारी S टा L. आउ कार, for example, देखो 1 to 2 to 3 normal rule R. This is R lactic acid. And this has to be found to be L. So it will be called R minus. This is L. Hence, its mirror image, you can make any switch. I can show you Chakma without putting a vertical mirror. I can interchange between these two groups, which will be definitely mirror image. If you manipulate the model, you can visualize the two are related by mirror images. But here, it don't look like. So I have outwitted you by not drawing a vertical mirror plane. I have made one switch. One switch means you are getting its mirror image form, which is non-superimposable with the old form. So this is S. You can prove it. 1 to 2 to 3. It is clockwise, but golden rule. This is S. S. And that is definitely plus. Supposing it is minus 20 degree, this is plus 20 degree. Plus lactic acid. But if you make a little change in 1 mile apart, I will make it methyl ester. But configuration is same R. COOMe. And all other will remain same. This will be called methyl lactate. Say R. The priority are not changing. Relative priorities are not changing because you are making a change miles away. So this will be R methyl lactate, but this is plus lactate. This is plus. And this is the, supposing I will interchange between these two to show you Chakma, that this is mirror image. This is definitely S and this is minus methyl lactate. You understood? So only changing to this, R was minus, here R is plus. So there is no fixed correlationship between absolute configuration and relative configuration. কিন্তু গোটাকর ফিক্স মানে ফিক্স আর ল্যাকটিক অ্যাসিডটা মাইনাস মানে এভরিওয়ার ইট উইল বি মাইনাস ইউ টেক আর ল্যাকটিক অ্যাসিড and put it in the polarimeter, it will give you minus, and specific rotation will be fixed. I don't remember, it is fixed, it is there in the literature. Got it?
Yes, sir.
Then
Yes,
a very important term is enantiomeric excess, EE. Sometimes it is called optical purity, OP, which is equal to EE or OP is equal to alpha sample, say specific, by alpha of the pure compound into 100. It's percentage. That means I give you a oral, I mean a verbal problem to you. Supposing butan 2-ol butan 2-ol ର D ଟା ମୁଁ D କହୁଛି ମୁଁ R କେସ୍ କହୁନି ମୁଁ ଜାଣିନି butan 2-ol ର R ଟା D କି S ଟା D I don't know ମୁଁ D କହି ଦଉଛି butan 2-ol ର pure D ହଉଛି +20 D ମାନେ +20 degree. Okay, ମୁଁ ଗୋଟେ chemical method, I used some chemical synthesis method. Usually we get a racemic mixture 50-50 ରହିଲେ it will be null, 50% plus and 50% minus, they will compensate each other and the result will be a racemic mixture which is inactive, which will be inactive. से केस रे मु से बड़े रेसिमिक मिक्सचर नहीं करी जदी मु पोलारिमीटर रे पहुंचीबी तुमे किछि अल्फा किछि अल्फा किछि मिलिबनी तेणु अल्फा स्पेसिफिक किछि मिलिबनी 0. किंतु जदी मु गोटे ब्यूटान 2-ol तयारी कली गली मेजरमेंट करिवा को, always when you are adopting a synthetic method, either you will get a racemic mixture, or if you are little witty, you have done some manipulation to get a particular enantiomer in larger excess than the other, then you will be getting an enantiomeric excess. Supposing you will get +10 degree, that becomes the alpha specific. You found out the concentration and length and divided by that, you got alpha of the sample that you have prepared as +10 degree. And I told you that you have prepared butan 2-ol sample. Plus means it has come, +10 means definitely excess D is there. But it is not 20. Had it been +20, then it would have been 100% pure D. Since you are getting 10 degree, obviously 10 divided by 20 into 100, 50% pure D is there. But what happens to the rest 50%? Tell me. If you have got 10 degree, then enantiomeric excess of D is 50%. Excess of pure D. And what will be the nature of the remaining 50% of the molecules? Yes. Anyone following in the YouTube can answer, can outwit these guys who are not able to follow me? Losing concept. Yes.
Lepo.
जदि 50% लेबो होई थांता 50-50 कटाकटी हेकरी 0 होई थांता +10 डिग्री केमते आसला सेतिके एक्सेस अछि बोली बाकी 50% कोन रुद्र तुम भांग फांग खाऊ बोधे एमती अवस्था हलानी तमर let me again explain to you had it been 100% pure D-butanol then alpha specific would have come 20 degree but the sample that you were given you found in the polarimeter alpha specific is found to be +10 degree so enantiomeric excess as per the formula 10 by 20 into 100 50%. So 50% excess of D-butanol is there. So what will be the state of or the fate of the remaining 50% of the molecules?
Sir, 25 D and L mixture.
Yes, the rest 50% is racemic. They have cancelled with each other without any contribution to rotation. The excess 50% D that has resulted 10 degree. We have 100% molecules. Out of which 50% molecules, their excess of D. They do not have their counterparts on L. Had there been counterparts, they would have cancelled each other. But the remaining 50%, out of 50, 25% will be D, 25% will be L. So they have cancelled each other, leaving behind excess 50%. So if I ask you, what is the total percentage of D in the mixture? What you will say?
The 75%.
75% D and remaining 25% L. So 25 they have cancelled with each other. Remaining their excess enantiomeric excess will be 50%. Got it, Miss Tripathi?
Yes, sir.
कालो मा जाने अरे एटा पर पब्लिक कोन होउची सो मु कोन एमती हेलेनी मुडे क्वेश्चन दोस तुमको सर्टेन राइट डाउन ऑप्टिकली active compound was prepared and found to have alpha specific 6 degree but its pure form now the only because I'm writing the numerical fictitious I mean without naming any I don't know whose compound has 6 degree its pure form has alpha specific is equal to +20 degree +20 degree calculate OP optical purity percentage same EE whatever EE is same as OP and also the total D forms and L forms present in the mixture.
Sir, Sir, optical purity is 30% and D forms 65% and L forms 35%.
So ago bhar kar dele OP by EE is equal to 6 by 20 into 100. एटार शून शून कटिगला 2 रे काटले 3 30% एक्सेस अछि D एक्सेस D प्लस माने D माइनस एता तो L तो बाकी 60% racemic that is 30% 70% sorry बाकी 70% होची racemic 35% होची D plus 35% L प्रथम आंसर टा हला एति 30% होची एनान्सियोमेरिक एक्सेस बा OP किंतु टोटल D होची केते D रो परसेंटेज केते ना 30 एक्सेस जुक्त एठी 35 हला 65% अछि ओनली D and L percentage होची 35%. So आ भितरु 35 को खाई गला. So 35 65 रु 35 चली गले और रहला 30 is the enantiomeric excess. Got it?
Yes, sir.
Miss Raipat,
Yes.
hi.
Yes, sir.
Now we'll be taking up two chiral centers. So, I was saying some other day that how cis is greater than tans. For example, on one side you have and in some other side the same group is there where hydrogen atoms are opposite. But this configuration is trans. Looking to hydrogen, their opposite is trans. This is cis. So they are different. They are not same. So cis has a greater priority than, but this is a chiral center is here. So this carbon, which is chiral, will be first, cis number 1, the entire group number 1, then 2, number 3, number 4. The 1 to 2 to 3 clockwise. So this is R. And you can name 1, 2, 3. This is a very symmetrical compound. So it will be 3R. You understood?
Yes, sir.
If both are cis, then it is achiral. If both are trans, then it is achiral. But one is cis, the other one is trans, but the group is same, and then they are also different. Similarly, you will find later when there are three chiral centers, on this side a chiral center is R, this side also R, then it is achiral. This carbon is achiral. This carbon is chiral because that is R and this is R. But the middle one is achiral. But if this is R, the other side is S, they are different, even if they are same structure but different configuration, then they will be treated as this middle one will be a chiral center. That is called pseudo chirality. Sometimes it will be achiral, sometimes it will be chiral, and that phenomenon is called pseudo chirality. I will talk about that just in a bit. Now let us write down two chiral centers. A symmetrical structure means you can have a plane of symmetry. Symmetry in one form, not in all forms. That means supposing the compound is like this is two chiral center. I am deliberately writing a symmetrical, to show a plane of symmetry here. Why the first compound having two chiral centers which was found to be optically active was tartaric acid. So this structure is this. This molecule is achiral because there is a plane of symmetry passing in the middle. This is a symmetrical molecule and this particular form has a plane of symmetry at the middle. So this is achiral. There is a PS because OH on the same side, COH on the same side. Horizontal means above the plane, Vertical means below the plane, so they are on the same side. So there will be an internal plane of symmetry which will make the molecule a chiral. But the two chiral centers can be assigned configuration in normal way as you have been doing before. Before we assign the configuration, there are two chiral centers. You know, each individual center is chiral because it's bonded to 4 different groups: OH, H, COH, and the rest, which I funnily say the Buddha, the entire bulky group containing carbon, hydrogen, OH, and COH. So there it is a chiral carbon. And the second carbon is also chiral bonded to H, OH, COH, and the same Buddha. But collectively, the molecule is achiral because there is a plane of symmetry. What to do? Because it's mirror image form, if you make, it will be superimposable. So they are one and the same. It doesn't have a different mirror image form, achiral. But if you make one switch at any one chiral center, there are two chiral centers, and this is optically inactive. This is called the mesoform. Mesoforms are optically inactive forms in molecules having chiral centers. This molecule has two chiral centers, but still it is inactive. In such a case, it is called mesoform, is inactive, achiral. But if we make one switch at any one chiral center, for example, I will make the COH exchange swap with H, and other will remain the same. Now, while OH group lying on the same side, COH are lying on the opposite side, although above the plane, but opposite side. And H are also lying on the opposite side. So you can never ever get a plane of symmetry, never ever get a point of symmetry, never ever get a SN axis. So this is achiral. And it has a different configuration. And you have to assign configuration at each chiral center. 2s, 3s, 2r, 3r, 2s, 3r, 2r, 3s. Like this we will be doing. Now, we can have its mirror image. Once it is achiral, no sigma, no I, no aja. So it is achiral. So if you just, can anyone tell me what I shall make unto this molecule? What surgery I will make unto this molecule so that I will get its mirror image form? So that I will get its mirror image form.
Just C2.
What's C2? You answer in with the help of switch. How many switches at which chiral center I have to make so that I will get a non-superimposable mirror image form? Achiral means its mirror image will be non-superimposable. Tell me, what shall I do onto the first form so that I will get its mirror image, which is non-superimposable?
Sir, we'll switch the COH group in both chiral centers. With hydrogen.
କାହିଁକି ସେମିତି କିଛି ମାନେ ଅଛି ହାଇଡ୍ରୋଜେନ ସାଙ୍ଗରେ ସୁଇଚ୍ କରିବି କିଛି ମାନେ ଅଛି ମୁଁ vertical mirror I have shown vertical mirror, therefore you are saying, supposing I will not put any vertical mirror and I want you to answer in a very broad based manner. I have to make one switch at each chiral center. I will interchange between any two groups at this chiral center and interchange between any two groups at this chiral center, so that I will get its mirror image, which is non-superimposable. And because I am putting a vertical mirror plane, so it is worthwhile for optics purpose, I mean, not your physics optics. I mean, looking good is optics. So I will interchange between these two, break and remake. Aku ta konaru bhar karibi, ethre pureibi, and aku a konaru bhar karibi, ethre pureibi. So that you get object distance is equal to image distance. So you think that they are superimposable, they are not, because these COH they are above the plane. And supposing I will make this model upside down, then COH will come to the left side. This COH will come to the right side, but they will be going below the plane, and this OH will come above the plane, which is now in the below the plane. So they are never ever superimposable. Hey, look into, I can show you the model. I will show. But why? You are intelligent guys. You can conceptualize. This is a projection formula. Shadow. Actually, the horizontal lines are lying above the plane and the vertical lines are lying below the plane. If I make upside down, then those which are horizontal will go down and those which are vertical will come up. Actually. And we cannot, according to rule, we cannot get the projection, Fisher projection formula is not done like that. The one which is down, we will make vertical projection. That is the rule for getting Fisher formula. But yes, we can say that they are non-superimposable. So the answer was to make one switch. Anyone, I could have switched between these two and here between these two, and I would have got the same result. But you cannot visualize immediately by putting a vertical mirror plane, but by manipulating the model, you will definitely find they are not only non-superimposable, but also they are mirror images of each other. You got it?
Yes, sir.
And these, if one is this, this is, we write DL pair. One is D-tartaric acid and one is L-tartaric acid. I do not know which one is which, but one is D, the other one is L. But let us assign the configuration. Now, apply the CIP rule individually. For this chiral center, number one group is OH, number two group is carboxyl, and number three groups is Buddha. Because this carbon is bonded to a carbon and an oxygen, but this carbon is bonded to three oxygen. So carboxyl group, had there been a bromine here somewhere, then ये ऑक्सीजन तीनों ऑक्सीजन को मात दे सकता था, लेकिन there is carboxyl, so there is one carbon and one oxygen, and here this carbon is bonded to three oxygen. So carboxyl is number 2 and Buddha is number 3 and number 4. And unfortunately we have to apply the golden rule. Number 1 देखो, number 2 देखो, Buddha को देखो. Our eye is rotating anticlockwise. So according to the golden rule, anticlockwise is what?
R.
So this is 2R. According to nomenclature, 1, 2, 3, 4. 2, 3 dihydroxy butane dioic acid. 1, 4 dioic acid is a must. You may not write 1, 4. Got it? So this
Yes,
is
sir.
2R and then 3. Let me tell you, if it is optically active, we have found that it is one is R, the other one is bound to be R. Because if other one is S, opposite configuration, they will cancel each other internally, and that would be a mesoform, optically inactive. That will happen in case of meso, where there is a plane of symmetry. You will find one is R, the other one is S. But here you apply the same rule. Here I am removing with my rubber to make the Buddha the upper one and Tokka the lower ones. The same rule we will apply number 1, number 2, and you draw once again. Or if you are using a pencil, you can remove it. And now the Buddha is this one. Number 1, number 2, number 3 is Buddha. Number 4, once again golden rule, number 4. 1 to 2 to 3 again anticlockwise and golden rule R. So this will be called 2R, 3R tartaric acid or 2,3 dihydroxybutane dioic acid or tartaric acid. Are we understanding, or something is going above our head?
Yes, sir.
Yes, sir.
No, sir.
ସବିନାନୀ ବୁଝୁଛ?
Yes, sir.
Now ଯଦି ଏଇଟା 2 or 3 r ଆଖି ବୁଜି ଦିଅ, close your eyes and say this is 2s 3s. Yes or no? Because you have inverted.
Yes, sir.
By making one switch at any one chiral center, you are inverting the configuration. You have made one switch. So R it becomes S and this R becomes S. So this is 2s 3s. Same tartaric acid. If 2 or 3 r tartaric acid is plus and I know it is plus, so this is minus. I know. Plus minus is only once. But as many number of chiral centers are there, you have to write R, R, S, S, R, S, S. Same number of times you have to write this capital R or S. But for the entire molecule, the optical rotation will be either plus or minus. So, and in this case, it will be, tell me the upper one. The upper one is a symmetrical molecule. So you can number, 2, 3 dihydroxy butane dioic acid, okay. Butane dioic acid is okay. But supposing you number from this side, 2 will be something, 3 will be something. If you number this side, 2 will be the other thing and 3 will be the other thing. That's the fallacy I will ask you later. But first, find out the configuration of the second carbon according to the numbering I have made. Upper one.
2s 3r.
देखो number 1 होची एटा, number 2 होची carboxyl, बुढ़ा number 3 and number 4 होची hydrogen, and we are applying the golden rule. 1 to 2 to 3 is anti-clockwise, clockwise. This is clockwise and golden rule is what?
Sir, S.
S. कौन तुम्हें कहलो?
The 2s 3r.
যদি এইটা এস হেলা তুমি জানিছ প্লেন অফ সিমেট্রি ଅଛି কটাকটি হেবে ডেফিনেটলি তার মিরর ইমেজ নয় কি তেণু মিরর ইমেজ মানে তার অপোজিট কনফিগুরেশন তার ভিতরে ইনসাইড ইট গোটে পার্ট হচ্ছে এস গোটে পার্ট হচ্ছে আর দিস হ্যাজ টু বি আর বিকজ আমি যদি লিভেই দবা তুমি লিভেই পারিবনি মু লিভেই দেবি বর্তমান নম্বর 1 এইটা হয়ে গলা নম্বর 2 2 and বুড়া নাও দিস ওয়ান and H 1 to 2 to 3 anti-clockwise and golden rule this is R. So this is 2s 3R and interestingly এপটু যদি নম্বরিং করিবা this can be 2 or 3s. So tomar common sense kohuchi in this particular case when there is a plane of symmetry the molecule is symmetrical in structure then 2s 3R is identical with 2r 3s. Yes or no?
Yes, sir.
Yes, sir.
जबरदस्ती मु तुमको आउरी क्लियरली बुझे दूची सपोजिंग यू मेक वन स्विच to get a theoretical mirror image you will see what will happen. Your upper one is S, you have interchanged once, so it will be R. So according to the same numbering nomenclature you have interchanged this also, it has also become S. So this becomes R, this becomes S. But you will find if you take the two models, they are superimposable. They are superimposable. Just make upside down, not this way, like this. You will find the two are superimposable. So in this case, 2s 3r is same as 2r 3s. 2s, these two are superimposable. They are one and the same. They are not different. Imposable. So এটা 2r 3s. So এটি লিখি দউছি 2s 3r is same as 2r 3s. তুমি ভাবুথ সারা কিছু বুঝি হেলানি মডেল দেখাইবে কোন যেমতি সুপার ইম্পোজেবল দেখাই দেবি কিন্তু এথরে সুপার ইম্পোজেবল হবনি এটারে এইটা অপটিক্যালি অ্যাক্টিভ কাইরাল সেন্টার ଅଛି দিটা এবং কোনসি এলিমেন্ট অফ সিমেট্রি তিনটা নাহি রাইট সো তুমি আউথরে টিকে ভালো সে করিবা ମୁଁ ତମକୁ ଏଇଠି ଦେଖେଇ ଦଉଛି ଦେଖ ପିଲାମାନେ ଗୋଟେ କ୍ଲାସ୍ ଦିଟା କ୍ଲାସରେ ସାରି ଦିଅନ୍ତି, ଡଜଣ୍ଟ ମ୍ୟାଟର, ସାରି ଦେବାଟା କିଛି ବଡ଼ ଜିନିଷ ନୁହେଁ, କିନ୍ତୁ କେତେ ଜିନିଷ ସେଥିରେ ଅଛି ଭିତରେ ପଶିବାକୁ ହେଲେ ଆମେ କହିବ କାହିଁକି ଭିତରେ ପଶିବା, ସେଇଟା କହିଲେ ତ ଅଲଗା କଥା ଯିବ, କିନ୍ତୁ ତ ମୁଁ ତ IIT ପିଲାଙ୍କୁ ଗାଇଡ କରିକିରି ଶେଷ ହେଲାଣି ମୋର ଜୀବନ, ତେଣୁ ମୁଁ ଜାଣିଛି ଦେଖ এইটা ଗୋଟେ ମୁଁ ଜାଣିକି ତିଆରି କଲି ମେଜୋ କମ୍ପାଉଣ୍ଡ, এইଟା ମୁଁ କଲି, this carbon carbon rotation is entirely free, but I deliberately am bringing it to eclipse conformation. I had a chance to distort the conformation. By distorting or changing the conformation, we are not going to change the identity or change the configuration, but to visualize a plane of symmetry, you have to bring to the eclipsed conformation, so that white ସାଙ୍ଗରେ ଯେତେବେଳେ eclipse ରହୁଛି ସେତେବେଳେ green ବି eclipse ରହୁଛି, blue ବି eclipse ରହୁଛି, then only you can visualize the molecule has a plane of symmetry. Yes or no?
Yes, sir.
So this is a
Yes,
measure.
sir.
If this is one is R, the other one is S. Supposing I will make one switch here, one switch here. Just expect something new is coming. Nothing new will come. If by numbering from this direction, it would be 2S, 3R. The same direction, it will be 2R, 3S, but they are superimposable one and the same. Such a molecule, you may not write 2S, 3R or 2R, 3S. You simply write SR, RS or SR, whatever, because both are same. It's a symmetrical structure. Now, I would like to show you ଗୋଟେ ଏମିତି ହେଇକିରି ହଜି କେତେ ହଜିଲାଣି କ୍ଲାସରେ ସବୁ କରିକି। ମୁଁ ଜାଣି ଶୁଣିକିରି ଦିଟା ଯାକ ଆଇଡେଣ୍ଟିକାଲ କରିଛି। ଦେଖ ଦିଟା ଯାକ ଆଇଡେଣ୍ଟିକାଲ କରିଛି, ବର୍ତ୍ତମାନ ଦେ ଆର୍ ସୁପର ଇମ୍ପୋଜିବଲ। ଦିଟା ଅଲଗା ଅଲଗା କରିଛି, ବ୍ଲୁ ଲେଫ୍ଟରେ ଅଛି, ଗ୍ରୀନ ରାଇଟରେ ଅଛି, ହ୍ୱାଇଟ ଅପରେ ଅଛି। ଗୋଟାକୁ ସେମିତି ମୁଁ ରଖିଦେଲି, କିଛି କରିବିନି। ଏଇଠି ଗୋଟେ ଏଥିରେ ଗୋଟେ ସୁଇଚ୍ କରିବି, ସେଥିରେ ଗୋଟେ ସୁଇଚ୍ କରିବି, ଆଜି ମୁଁ ଗୋଟେ ମିରର ଇମେଜ ଯେମିତି ଆକ୍ଟିଭରେ ପାଇବା କଥା ସେମିତି ପାଇବା ପାଇଁ ମୁଁ କରିବି। It will look like mirror image ଲାଗିବ, କିନ୍ତୁ they are not mirror image। ଦେଖ ଏପଟେ ମୁଁ ସୁଇଚ୍ କରୁଛି, ଏନି ସୁଇଚ୍, ନଟ୍ ନେସେସରି ଲେଫ୍ଟ ଆଣ୍ଡ ରାଇଟ୍, ସେମିତି କିଛି ମାନେ ନାହିଁ, ଏନି ସୁଇଚ୍ କରିବି, and ଏଠି ଏନି ସୁଇଚ୍ କରିବି, ସେଠି କିନ୍ତୁ ମୁଁ ମିରର ଇମେଜ ପାଇବି, which will be not superimposable। ମୁଁ ଦେଖେଇଦେବି, ହେଲା। ଏଇଟା ଦେଖ, ଚାହିଁଲେ ତମେ ମିରର ଇମେଜ ଭଳିଆ ରଖିପାରିବ, ଚାହିଁଲେ ମିରର ଇମେଜ ଭଳିଆ ରଖିପାରିବ, ବଟ୍ ଦେଖ ମୁଁ ଟିକେ ମଡେଲଟାକୁ ଏମିତି ବୁଲେଇଦେବି, କିଛି କରୁନି, ମୁଁ ରୋଟେସନ ବି କରୁନି, ମୁଁ ଖାଲି ହାତରେ ମଡେଲଟାକୁ ବୁଲେଇ ଦଉଛି ଏମିତି। ବୁଲେଇଲେ ସୁପରଇମ୍ପୋଜିବଲ ହେଲା କି ନାହିଁ? ଆଉ
Yes, sir.
it looks
Yes,
like
sir.
mirror image, looks like mirror image ଗୋଟେ ରଖିଦେଲେ ମୁଁ କରିଦେଲି ପରେ mirrors ହେଇଗଲା କିନ୍ତୁ ପ୍ରକୃତରେ they are not mirror image, they are superimposable. ଏମିତି କରି ବୁଲେଇ ଦେଲେ ସେ superimposable. So they are one and the same. Symmetrical structure ପାଇଁ mesoform ଗୋଟିଏ ଥାଏ, ଗୋଟିଏ ଦିଟା chiral center ରେ. So let me write down something about mesoform. Is there is a plane of symmetry and hence optically inactive due to internal compensation. सेटा हला racemic mixture टा थिला external compensation, एटा internal. कारण गोटे हाफ आ गोटे हाफ रो ऑपोजिट 2s 3r is equal to 2r 3s mesoform. तेणु अधाटा आउ अधाकर मिरर इमेज गोटे फाळे आर फाळर मिरर इमेज. सो ये क्लॉकवाइज बुलेबा को चाहिले से एंटी क्लॉकवाइज से इंटरनली मॉलिक्यूल इंटरनली दे विल compensate each other and the optical rotation is zero. So it is inactive due to internal operation. And the active forms, there are two active forms. Now tell me mesoform को active करियो को हेले कोन करियो पड़िबो के कहि परिबो? मेजोफॉर्म टाकु मु एक्टिव करियो को चाहूची कोन कले सेटा डिसिमेट्रिक हे जीवो, सिमेट्रिकल रु डिसिमेट्रिक हे जीवो कोन कले. Guys who are watching in the YouTube, I am also equally concerned with you if at all you are following me, but I am finding that many they are just switching on, just seeing what is going on and they are going out. कोई बात नहीं. मुझे लगा अगर कोई बाद में किसी को इसी का फायदा उठाना होता है तो मैं खुश नसीब समझूंगा. मेरे एक्सपीरियंस कुछ किसी का तो काम दिया. मेरे एक्टिव होने तक मैंने तो कुछ करने के लिए कोशिश किया. तो
doing a single doing a single switch doing a single switch in one chiral center.
Yes, by doing a single switch at any one chiral center. एटा हो कि एटा हो कोटा गुटे करदेला माने अवश्य सेटा आर ही पारे कि एसएस ही पारे, doesn't matter, I don't know, but by making one switch at any one chiral center, not both the switches, गोटे switch जदि कर दबो, the mesoform is converted to an active form and active आर ही पारे कि एसएस ही पारे by making one switch, any one switch at any one at one chiral center and vice versa. माने एक्टिव फॉर्म को यदि तुम मेजो फॉर्म करियो चाहूचो, you make one switch at any one chiral center, then it will be converted to meso. You will find a plane of symmetry when you try to manipulate the conformation, bring it to the eclipsed mode center and vice versa. Got it? So ame एटा मेजो कले आउ
Yes,
थरे
sir.
कले कारण सेठी बहुत गंडगोलिया करिचे. आमे एठी कले COH एथरो टिके चेंज कर देले, नॉर्मल रूल अप्लाई करियो की इच्छा हला, डजंट मैटर, आमो इच्छा. एटा मेजो थिला, मेजो रे एपटे RS हेले तार मिरर इमेज तो चेष्टा करिवो जे सेटा एक्चुअली मिरर इमेज नै, दे आर वन एंड द सेम. गोटे R हेले कहले एटा R ना S एपट आडू जेहेतु जेमती लिखिचे से अनुसार हमें करियो पड़िबो. ऊपरटा R ना S, गोटे R गोटे S हबो. प्लेन ऑफ सिमेट्री अछि माने गोटे R गोटे S हबो. दे विल किल ईच अदर्स रोटेशन and the net rotation will be 0.
सर ऊपरटा
नहीं
R
बालिका बालिका मो नातुणी बस तमे मध्य इक्वाली डियर टू मी हाँ कौन कहूला मिस त्रिपाठी कौन कहूले गोटे
No, sir.
अरे गोटे बालिका तमे कौन ओमकार तो अमिताभ बच्चन बालिका साउंड कौन तमे रुद्राणी हो गल कि अरे पब्लिक वीडियो एटा ऊपरटा कौन
सर R
ओमकार
Yes,
समित
sir.
समिधा
Sir, R.
जानी होनी
Yes, sir.
कौन ऊपरटा
Sir, R हब.
देख तुम पेनसिल रे करिवो तने लिभेबे पड़िबो ना बारंबार देख मु लिभेबी ओएस टा नंबर 1 सीओएस टा नंबर 2 देन बुढ़ाटा नंबर 3 1 2 3 क्लॉकवाइज बुलुची एवं एटा नॉर्मल रूल चारिटा वर्टिकल पोजीशन रे अछि एटा आर तेणु मु लिभेबी कारण मोर एते कॉम्प्लिकेटेड करिया को मु चाहुनी बट फाइनल नोट रे सो एटा आर एटा कौन हबो जदि एटा आर एटा कौन हबो कौन
सर S
अनडाउटेडली एस हबो एठी नॉर्मल रूल पकेले एस हबो काहे ना हम जानिछु एटा गोटे आर एले एस एले प्लेन ऑफ सिमेट्री माने एटा कायरल सेंटर सॉरी एटा अकायरल मॉलिक्यूल टा अकायरल ऑल्दो देयर आर टू कायरल सेंटर्स बट द मॉलिक्यूल एज ए होल इज अकायरल इज सिमेट्रिकल and since गोटे r हेले गोटे s internal compensation हबो so this is r comma s 2r 3s हो कि जा को पट नंबर जो पट नंबरिंग कली तो एका उल्टे देले भी एका जिंस हो then we are converting one switch हमें कले one switch कले हमें थोड़ा ऊपर करिबा कि तळ करिबा ऊपर कला माने हम जानि परलु एटा r टा s हे गला ss पाइ दिबा तळे कला माने r r पाइबा कोटा करियो चाहू तमे अरे तुम छोट पिला तुम भाबुथु एसे कौन छोट पिला बेली भाबिलानी हमको
सर डेटा को R करता
आर आर कर दो तळटा को करियो चाहू ऊपरटा को से कहूची
Yes,
आर
sir.
थाउ तळटा को स्विच कर देले सेटा एस टा आर हे जिवो एटा को मु मन इच्छा कर देबी कारण वर्टिकल सेमति मिरर प्लेन रखुनी तो मन इच्छा आर भीतर कर देबी पिला माने बुझी परिबेनी अरे वर्टिकल तुम चेष्टा करनो करिक मॉडल देखो यू विल बी गेटिंग मिरर इमेज एनीवे मु एटा कर दे सीओएच एटा ओएच एटा को कर देली सो दैट एटा तो आर थिला आर तो किछि करिने एटा को हम आर कर देले सो एटा को 2r 3r लिखियो पड़ियो एटा मस्ट टार्टरिक एसिड जागा नाही तमर जागा थिले एठी ऑलरेडी जानिचो एटा एटा आमी जानिछे एटा डी बोली नने तमे कहि परिबो अनलेस यू नो इट नाउ आउट लेख बाय मेकिंग ना लिखि सारिछे वन स्विच एट ईच कायरल सेंटर तमे कहिथिलो आमे लिखिछे ना नाही नानी
Sir.
लिखिछे आमे
No, sir.
हाँ मुंड काम करू ना स्कूल रू आसिकरी ये करी आसिकरी ट्यूशन फ्यूशन ये करी पुणी ये हार्ड कोर जिनस आउ मुंड काम करू ना बाय मेकिंग वन स्विच एट ईच कायरल सेंटर we convert one enantiomer to the other एटा लिखि दियो तळे एटा एक्टिव हे गला एक्टिव फॉर्म एटा डी हमें जानि छे डी 2 और 3 आर कारण एतर प्लेन ऑफ सिमेट्री नाही कि आई नाही कि अजा नाही मु देखै देबी वर्तन अजा आई सब देखै देबी नाही तेणु एटा chiral molecule as a whole is chiral सेठी molecule as a whole was a chiral although there were two chiral centers one enantiomer to the other so मु आउथरे लिखुची एटा को कारण सेठी जागा नाही सेठी कॉपी करूची OH COH एपोटे थिला एंड एपोट को चली आसला चेष्टा कले भी जेते कन्फर्मेशन चेंज कले भी तमे पाई परिवोनी प्लेन ऑफ सिमेट्री देखि परिवोनी so एटा chiral and एटा जदि RR हैला and how to get its enantiomer by making one switch at each chiral center any switch किंतु जेहेतु गोटे वर्टिकल मिरर प्लेन लगे देचे आखि को देखा आखि दृश्य हम नहीं तेणु लेफ्ट एंड राइट भीतर मु चेंज कली बट विथ a caution that any switch will do you will have the same result so एटा जदि आर है ऑब्वियसली एटा करवा दरकार नहीं एसएस एटा 2R 3R टार्टारिक एसिड एटा 2S 3S टार्टारिक एसिड एटा जदि डी है मु जानी बोली डीएल लिखिली नॉन एमती लिखि था डीएल पेयर एटा मु जानी टार्टारिक एसिड केस रे 2R 3R टा डी and therefore it is L. You got it?
Yes, sir.
Yes, sir.
So ए केस रे तुम गोटे रेसिमिक मिक्सचर पाई परिबो जदि डीएल मिक्सचर पाई परिबो जदि 50% आरआर टार्टारिक एसिड बा डी टार्टारिक एसिड संगरे एक्जाक्टली 50% एसएस एटा गोटे अलगा को फॉर्म नुए तीनटा टोटल फॉर्म स्टीरियोआइसोमर तीनटा डी गोटे एल गोटे आरआर गोटे एसएस गोटे there are two enantiomers and RS which is equal to SR is another, we can call it optical isomer, but it is strictly a diastereoisomer, a diastereomer because that is not the mirror image of any one of the RR or SS. So the relationship between RR or SS with RS, that is meso, is diastereomers, mesoform. So SS tartaric acid, that is optically inactive due to external compensation racemic mixture. But so let us define diastereomers now in the context of optical isomerism. Meso and any one of active forms, either RR ho or SS ho, are diastereomers. Because they are not mirror images. RR sangare SS mirror image, RS sangare SR mirror image. आमे देखिबा जदि नेक्स्ट टाइम हमर समय हो गलानी नेक्स्ट टाइम आमे देखिबा काली जे जदि अनसिमेट्रिकल मॉलिक्यूल ही थाए RS is not same as SR, they are mirror images. So से आ गुटे पेयर हो ये गुटे पेयर से गुटे पेयर टोटल चारटा एटी तीनटा आइसोमर्स हबो स्टीरियो आइसोमर्स तीनटा हम ताको बेले ऑप्टिकल आइसोमर्स कहि दो किंतु ऑप्टिकल आइसोमर्स स्ट्रिक्टली दीटा SS and RR they are enantiomers and RS which is equal to SR seta sangare any one of these two will be diastereomers. So we are closing here. I mean it diastereomers more the definition I mean daba at least one chiral center has same configuration. सबुड़ा जो उल्टी गला तो सेटा ही गला एनांटियोमर जदि तीनटा कायरल सेंटर अछि क्रमान्वय रे सबुड़ा को उल्टी गला तले से तार मिरर इमेज हे गला एटलीस्ट गोटे समान थिबो बाकी गुडा को उल्टी उल्टी सेम रहिला सबुड़ा को सेम रहिला से सेम कंपाउंड हे गला जते प्रकार उल्टा पलटा लिखिले ताको कहंती होमोमर्स the appearance, the structural representation, the form that you represent in pen and paper, they are looking different, but actually they are same configuration in that they are called homomers in the drawing. But the change karibo, sabu change kari par excepting one remaining same, then that will be a diastereomers. They are not mirror images. Sabudak change kar dele hijibo kon enantiomers. So RR and RS. This is a pair of diastereomers. SS and RS. Same thing, they are same. They are also another pair of diastereomers. This is other pair of diastereomers. And diastereomers have different physical properties. The RR and RS, meso and active. Meso and any of the active forms are diastereomers and have different physical properties, and they can be separated easily. The mixture ହେଇଯାଇଛି meso ସାଙ୍ଗରେ DL ମିଶି ଯାଇଛି, mesoଟାକୁ ଆରାମରେ ବାହାର କରିଦେଇ ପାରିବ, ତାର boiling point melting point ଅଲଗା, କିନ୍ତୁ D and L କୁ separation କରିବା ଟିକେ difficult, and that we have to adopt some special technique. Diastereomers have different physical properties. And can be separated easily. RR and SS, they are gone. They are gone.
Enantiomers.
Enantio. I was also saying enantiomer for a long time until I found the actual pronunciation. They are saying enantiomer. I was really surprised when the native speakers are saying enantiomers. So I had to change my pronunciation, enantiomers. I can testify that by showing you the Google here.
Enantiomers.
Are you able to hear?
Yes, sir.
Enantiomers.
You're looking at how to pronounce these words, as well as how to say more interesting but often confusing words and names from science. The name of these chemical compounds. How do you say it? Enantiomer. Enantiomer. Stress on that second. Nouns.
Got it?
Yes, sir.
Yes, sir.
You know, until the last year, I mean, a year ago,
Yes, sir.
I got it corrected. You know, till the last breath of your life, somebody's life one has to learn. Learning is never complete. And these are enantiomers, have all identical properties, excepting कौन कहती कौन कहती all properties, physical properties, chemical properties, all identical, excepting
PPL response.
yeah, very good. এটা বালিকা না নাই
Yes, sir.
তুমি কইল তুমি তো
No, sir. No, sir.
the response to PPL. Sometimes smells are different, biomolecular. Sometimes their odors are different. Sometimes. With this, we conclude today. Bye-bye, those who are watching. Tomorrow will be the last class before we break. And then we will start, hopefully from 1st. Hopefully from 1st of January 2025. Tomorrow, I will wish you a happy new year because we'll be breaking. Bye-bye.